So welcome everybody. My name is Luis Soares. Like Alex just said, I'm here from Portugal. And yeah, I was born and raised in Portugal. I love everything that has to do with high availability and fault tolerance, in addition to a few other things. I've been doing MySQL for a somewhat long time now, 16 years, going 17, I guess. And today I'll be talking about one of my favorite topics, which is high availability, in particular, high availability in the HeatWave MySQL service. So this is the agenda for today's session. Basically, talk a little bit about background on availability, fault tolerance, and so on. Then talk about features in the HeatWave service that allow you to handle failures automatically by the service and therefore offload that to the service instead of dealing with it yourself. And I'm going to talk also a little bit about the latest developments over the last roughly 12 months that we've been doing in these areas, right? So background, important concepts are things like RTO and RPO. One relates to the time it takes to recover from a failure. The other one, RPO, relates to the time to the amount of data that one is able to lose when there's a failure and we have to recover the systems and so on and so forth. Both of them have influence to what we define as our service level agreements, right? So one relates to the time it takes to recover, one with the amount of data that one can lose in the event of a failure. Failures themselves, they have different types, right? They can be human, caused by human mistakes. They can be due to disasters, so a much larger scale type of failure. They can be just due to bugs or due to some problems in the software or infrastructure and so on and so forth. Also, within this section of the background, I would like to say one thing about MySQL. We're celebrating 30 years of it. From the early days even, MySQL has been, it has had MySQL replication built in, right? So it's a proven technology, battle tested, which has been used out there worldwide across different industries, very flexible. So it's a very well established technology for a good foundation to build high availability. In addition, with the advent of things like row-based replication and so on, the replication technology became even more than just something that you could use to build redundancy. You could actually use it to build things like capture data changes and data integration and so on and so forth. Now, we have the HeatWave MySQL service that builds on top of MySQL itself and MySQL replication technology to provide high availability, so a resilient, reliable data store using MySQL. We can have high availability within a cluster. We can have other types of fault tolerance by solutions by doing things like cross-region replication between clusters to, for instance, deal with disaster recovery scenarios and so on and so forth. All of this, a very big part of this, managed for you, for the users, right? You don't have to deal with it other than setting things up, launching a DB system, creating a channel between DB systems to replicate within these two DB systems, enabling HA within a DB system, and so on and so forth. All of this running at scale, all of this running with or handling heterogeneous workloads and running in the Oracle cloud infrastructure. So I talked a little bit about this as well, but some features to highlight: high availability through redundancy within a cluster, inbound and outbound replication. So replicate into a DB system, out of a DB system. By the way, I didn't say it, but a DB system is just an abstraction over a MySQL database, which kind of abstracts away from the user all these things, internal things like, is replication going on, is the cluster up and running, are we doing backups, and so on and so forth. So it's more of an abstraction over the database itself, right? So in and out replication, read replicas for read scale out, point in time recovery, and high availability, all within this managed service, right? So the way the system does high availability is that when you launch a system and you enable a DB system and you enable HA, it just creates a cluster. There's a primary to secondaries. The cluster itself runs distributed algorithms to decide, okay, was there a failure or not? If there was a failure, let's automatically select a new primary, and automatically deal with the failure itself. No need for the user to be called into action. No need for even for operators to be called into action. The system itself will react alone. So that's why I say automation, self-healing, distributed recovery, all these things are built into the system. Yes, the deployment is single primary and two secondaries, meaning that there's a primary deployed in some fault domain or some availability domain, and the other two secondaries are deployed on different fault domains and availability domains as well to make sure that if there are failures correlated with the availability domain that one is in, they don't kind of correlate with failures of secondary. So if a primary fails in 81 because something is going on in 81, the two other secondaries are not affected as well. Read scale out. So the read scale out is the ability to launch read replicas within the DB system. So a read replica takes a copy of the data itself. It runs with that copy in read-only mode, so you can query the read replica and so on and so forth. Allows you to offload the cluster from if you're doing a lot of reads, it allows you to offload the reads to the read replicas instead of running this read workload alone or all of it through the main cluster. All this is managed, so you can just say, okay, launch a read replica, and everything will happen under the hood. You know, the cloning operations, setting the instance up, bringing up the endpoint, bringing up a load balancer endpoint, and so on and so forth. And yeah, I've already mentioned this. So there's also when you launch a read replica, automatically is also provisioned a load balancer for your application as well. Replicating in and out, it's one thing that you can do because of migrations, because you want to just have a copy of your data elsewhere in another DB system, for instance, in another DB system in a different region for protecting against disasters and so on and so forth. Or you can just replicate to on-prem as well, right? Or from on-prem to the cloud. So it will work seamlessly that way. And one thing that is also important, especially when we talk about RPO, is things like backups, right? In the service, there's provision for you to do automated backups or to enable automated backups so that the system takes automatic backups of your data. In case something goes terribly wrong, you can always restore from a backup and so on and so forth. There's also the possibility to restore your data to a point in time as well. So you can just, using one of the automated backups as your base restore, you can roll forward bin logs to a specific point in time. All of this is done and managed by the service. You just have to say, I want to restore this DB system to a specific point in time, and then the service itself will handle all of these restore operations as well. Of course, this requires automated backups to be on and point in time restore to be on. So what have we done in the latest 12 months or so? We've we've improved this inbound replication by this is a very low level type of thing, but I think it's worth mentioning in the sense that it gives some idea of what users can do in terms of handling connections from a DB system to maybe on-prem and so on and so forth. So one thing we did last year, over the last year, was when we have this outgoing connection going from our DB system, meaning our DB system initiates a connection to, for instance, on-prem to start replicating from on-prem to the DB system. We make sure that the outgoing packets are assigned the IP address of the read-write endpoint of the DB system. In that case, you can, for instance, write your own, I don't know, firewall rules or traffic filtering rules to say, okay, this is actually coming into my infrastructure on-prem or elsewhere, and it comes from a reliable IP that I know about, so I'll let it through, right? If it doesn't, you might just decide to drop the packets, right? So this is a feature that is important that way. We've also worked towards reducing the time it takes to recover from a failure. So remember, a DB system running with HA enabled has 3 servers. One is the primary, there's 2 secondaries. The primary may fail at any given point in time, and when the primary fails, there's a failover to the new primary, right? This is a very oversimplified view of whatever happens. Typically, there's detection involved, time to confirm that the actual primary was failed. There's a promotion of the new primary. Take one of the secondaries, promote it to become a primary, and then fail over the application. Typically detection, so suspicion, detection, server failover, and then application failover to the new primary. What we've done is that we worked hard to improve things like the detection timings, fine-tune those timings, and also enhance the procedure to fail over the application to the new primary. So this actually reduced quite a lot the time it takes for the whole failover procedure to take. So this is something that we're really proud of as well. One of the things that you can probably imagine is, okay, I'm running a DB system or a cluster. Let's say that I'm running a cluster with many different instances within the cluster. Maybe I just have a cluster for HA, or maybe I have a cluster with read replicas as well, and I want to do a configuration change across all these instances, and I want it to be online, right? If you think of it, it's like you have either to roll out the configuration change across all the servers, or you do it all at once if the configurations are not incompatible between the topology of the system and the configuration values that we're changing. So at the end of the day, what you want to do is to make it online as well, right? So what we've done as well is that we, with a single update to your DB system saying, now I want my DB system to use this configuration instead of the other one, we can do it so for those system variables that are dynamically changeable and that do not require restarting background threads. We did it so that this is all online, so there will not be any service interruption in those cases, right? The primary is still there, your workload is still running, it's just that the system is morphing over time, the configuration, without having impact on your workload. So also, one thing that the system allows users to do is, okay, I'm running with HA enabled, and I know that there's a primary and 2 secondaries, and the primary is in, let's say, 81, availability domain 1. But I don't really like the fact that it is in 81. I would prefer that the primary is in 82. So I want to change, I want to do a switch over of my application from the instance that is running on 81 to the instance that is running on 82. The system allows you to do that it's a normal update on your DB system saying my preferred placement is now 82 instead of 81. And the thing that used to happen was, okay, this is, we'll start triggering a user-initiated switchover of the application, but if the application continues to uninterruptedly write to the database, the system would wait indefinitely until transactions would stop, right? Which could lead to starvation if the application doesn't stop, right? So what we've done is, okay, after 5 minutes, the system will block new incoming transactions. It will, actually, when you start the switchover, the system will block new incoming transactions, and after 5 minutes, it will just kill the ongoing transactions, right? So after that threshold is reached, we'll say, okay, all non-committing transactions will have to stop now, and we will switch the application to the new primary. This is actually something that users have expressed desire to do so, because having a system that starts a switchover and stays in that mode for quite a long time is not really good. We've also done a lot of work to make this overall system much more efficient. Basically to, first of all, increase the throughput of the system in terms of transactions processed per second. When we're talking about high availability, we're talking about whatever data change we produce in the primary, it has to go from the primary to all replicas, right? Especially in a cluster where things have to go more or less at the same pace. Why do they have to go more or less at the same pace? Because if the primary is much faster than the secondaries, it just starts creating a backlog, and the secondaries have a backlog that keeps increasing. If there is a failover, we need to wait for the backlog to be applied, and in those cases, it means that the time it takes to recover from a failure could be long, right? So when we're talking about an HA cluster, and we're talking about making the HA cluster have good throughput, what we're actually referring to is, or in addition to what is one of the implicit assumptions here, is that the data change has to propagate throughout the entire cluster in a way that is not creating lag. Because again, if there's a failover and there's lag, there's higher chance that the failover will take more time. For instance, GR itself, or group replication, which is the technology that powers HA in HeatWave, has things like flow control built in. So if there's lag on the secondaries, it starts making sure that the whole cluster is progressing at the same pace, which could mean some throttling here and there and so on. The purpose of all of that is really to make end-to-end throughput the same, or the most uniform across the board, right? So it's important that the replication applier on the secondaries works fast. So we've done work to improve the throughput on the applier. So the faster the secondaries are applying the replication log, the faster the primary will be, because there's no negative feedback in flow control. So the applier, the primary will be able to commit more transactions, will be able to generate more log per unit of time for the secondaries to process as well, right? So that's point number one. Point number two is, when there's a cluster running, there's some metadata that has to be kept in memory, and who is around, who's lagging behind, for how long, which roles have been changed, and so on and so forth, right? So what we've done is to optimize the way we manage this information in memory while the cluster is running, during the runtime of the cluster. These optimizations have led to less memory consumed and a faster management of the cluster metadata, meaning a transaction has to do less operations to commit in the cluster as well. Or there are less operations to be done to agree between all different instances within the cluster to commit a transaction. And we've also worked on replacing damaged instances automatically more efficiently. Not just like, okay, let's replace the whole compute and whole data, but maybe just replace the data itself by recloning from one healthy instance. So if we have one unhealthy instance, we may just reclone one healthy instance and make the unhealthy instance healthy again by just rebuilding on this clone. We've done as well that for managed read replicas, sometimes something bad can happen with a replica that can lead to replication breaking beyond recovery, and the system is able to automatically recover these read replicas as well, right? So early on, this is not for every type of failure, but in those failures that we have identified so far, we can make the system automatically recover the read replica by replacing it. And early on, in some cases will be, okay, this read replica is unhealthy, is quite damaged. Mr. User, if you could go in just automatically, if you could just go in and delete the read replica and recreate it, then you get it up and running. Now the system handles that as well in certain use cases that we have identified. So this is a kind of an improvement to the user experience because it doesn't have to loop in the customer in certain cases. The customer or the user, right? One thing also that some of our users actually, really wanted is, I want the ability to put a DB system, a cluster, in read-only mode. So why was that? Why do you need a DB system to be read-only, right? And the use case is basically, yeah, I'm setting up my disaster recovery personal solution, right? And I create a DB system 1 in region 1, and I create a DB system 2 in region 2, and DB system 2 replicates from DB system 1. And that's all great, right? But I really want the DB system 2 to be read-only because I don't want my application or some user mistakenly writing to that DB system 2, which could lead to data divergence, right? So to protect against accidental writes in DB system 2, which is technically a standby of DB system 1, I want to make DB system 2 read-only, and if there's ever the need to write to DB system 2 because DB system 1 just went away, I want to personally make it writable again. Basically, typically that would be the DR failover scenario, right? So it's a protection against mistakes done on DB system 2 by accidentally writing to it. We've also done point-in-time restore for deleted DB systems. You can, when you delete the DB system, you can choose to retain its backups for some time, right? Over time, these backups, if the retention period elapses, over time, these backups are deleted and so on and so forth. What we've done as well is, okay, for point-in-time restore to work, we need a base backup and then a collection of bin logs to roll forward on top of that base backup until the point in time we want to restore the DB system to. So now we also back up the bin logs and we retain them together with the automatic backups so that we can, if we wish to, after deleting a DB system, also restore it to a specific point in time because the bin logs are backed up as well. As automated backups are purged because retention period has elapsed, so will the bin logs as well. We've also added one interesting thing, which is I want to launch a DB system, and the DB system shows up with a read-write endpoint. That's the that's the endpoint that I connect to interact with my database. Some users have expressed the willingness to, or the wish to, okay, I want a DB system that actually has two endpoints from the get-go. I want a read-write endpoint and the read-only endpoint. And the reason is I want to, start prototyping some application that parts of it will write and parts of it will read. And as the system grows, and once we go from a prototype to production, and I want to scale out my system, and then I create read replicas and so on, I already want from the get-go to have my prototype, my application, realizing that part of it will connect to a read-only endpoint, part of it will connect to the read-write endpoint. Basically, allows the user to think in terms of, I want my application, parts of it to connect to a read-only endpoint and parts of it to connect to a read-write endpoint from the prototyping phase onwards. There's a lot of details about this, meaning, okay, what happens if I launch a DB system? There's a single instance. Where is the read-only endpoint going to point to, and so on and so forth. This is all in the manual. If I recall correctly, the read-only endpoint in that case will be directed to the primary as well. And by the way, the read-only endpoint doesn't really enforce that the connection itself is protected against writes. So it's more of a semantic abstraction that says this should be the endpoint that you connect to if you want to do reads, and this should be the endpoint that you connect if you want to do writes. And there's also scheduled cross-region backups. This is also relevant for the case of things like DR, right? Say that, okay, I want to start a DB system in some other region, and I want my backups to be copied to that other region periodically, right? You may choose to do something like, okay, I have my DB system every midnight or so, I take a backup and I copy it over to another region, right? If my DB system in region 1 fails and I copied my backups to region 2, I can launch a DB system in region 2 from that backup. And by doing the scheduled backup, cross-region backup, what you get is a backup image on region 2, which is periodically refreshed, right? So there was, before this feature, there was manual cross-region backups, and now you can also schedule it so that the system automatically does it for you. And I think this concludes the list of latest developments, and what we've seen in this presentation was, there's a lot of stuff, a lot of automation, a lot of interesting features that exist in the service itself. Things that the service does for the user, things that the service does and automates on behalf of the MySQL users, so that the users don't have to do it themselves. What this session didn't show is there's also a lot of interesting stuff that we've done internally to continue to expedite, improve, optimize the automation frameworks that we run. I focused on this session only on things that are more user visible, like the things I presented, but in addition to those, we've also improved quite a lot the automation in the service from the operations standpoint. So so the MySQL or the HeatWave MySQL service has a very strong focus on business continuity, whether it's a very good plethora of backup features, backup and restore features, to HA, to Scaleout, and so on and so forth. And we've continued to improve the system in the last 12 months in these three big areas: performance, reliability, and efficiency. Moreover, we try to also improve the user experience when users engage with the system as well. Like I said at the beginning, all of this powered by a well-proven, well-known, well-established MySQL technology. From the very early stages of MySQL, replication has been around for quite a, in it. So it's something that exists for a long time now, and it's something that we continue to leverage in the MySQL, in the HeatWave MySQL service. So with that, I conclude my session. Thank you for being here and listening. Are there any questions?